Welcome back to my channel, Math and Language, and we're going to discuss how to solve logarithmic equations using the properties of logarithms. Let's start. So first one, we have the equality rule, and it states that log base b of m is equal to log base b over n. So b here is the base, and m and n are the arguments. So if you have this kind of equation, remember that m and n are equal if and only if they have the same base. So let's have the example equation. Log base 10 of the quantity 5x minus 1 is equal to log base 10 of 3x. So the arguments here are 5x minus 1 and 3x. They have the same base, meaning so to find the value of x, you just have to equate these two arguments. So that will be 5x minus 1 is equal to 3x. Now, algebraically, to find the value of x, that will be 2x is equal to 1, and x is equal to 1 half. Now, let's check it by substitution property. So 5 times 1 half minus 1 is equal to 3 times 1 half. So 2.5 minus 1, and on the right side, that will be 1.5. 2.5 minus 1, that will be 1.5. And also on the right side, that will be 1.5. Means that we are correct. Let's have the next one, product rule. What if we have in the equation log base b of m plus log base b of n? So for this one, they have the same base and you want to add the two logs. So how to simplify that one? You can multiply the arguments to each other. So that will be log base b of m times n. If and only if their bases are the same and it's a plus sign. Now let's have the sample equation. Log base 3 of x plus log base 3 of the quantity x minus 6 is equal to 3. So again, they have the same base and you want to add these two logs. So that will be log base 3 of x times the quantity x minus 6. Now, for this one, you can just distribute the x. That will be x squared minus 6x. Next is, we can do the exponential form. So this is color coded so you can see which numbers, where the numbers go. So 3 cubed, the 3 here will be here, is equal to x squared minus 6x. So simplify 3 cubed, that will be 27. It's equal to x squared minus 6x. Now, we will get a trinomial here. So that will be 0 is equal to x squared minus 6x minus 27. Now, to find the value of x, we need to factor this trinomial. Factor this trinomial. So that will be the quantity x minus 9 multiplied to the quantity x plus 3. So the value of x will be x is equal to 9 or x is equal to negative 3. Now let's check. Which answer will we accept? 9 or negative 3? So let's start with x is equal to 9. Let's substitute 9 in the value of x. So we'll get log base 3 of 9 plus log base 3 of the quantity 9 minus 6. Simplify it. So that will be log base 3 of 27. So how do you get 27? Remember, you're adding two logs. And they have the same base. So 9 times 3. We got 27 here. Now, exponential form. 3 cubed is equal to 27. And 3 cubed is 27. And that is correct. So this is true. X is equal to 9. So this equation is true. Now we have another answer. X is equal to negative 3. So let's substitute it. Log base 3 of negative 3. So here is negative 3 minus 6. And logs of negative numbers are undefined, so it is false. So we cannot accept this answer. We can only accept the answer going back. Let's go back. X is equal to 9 only. Alright, so let's move on to quotient rule. So quotient rule, for example, we have log base b of m as an argument minus log base b of n. A while ago, we have talked about adding logs. How about we're going to subtract logs? So if it's subtraction, we use the quotient rule. So that will be log base b of m over n. If and only if they have the same base. So let's have the sample equation. Log base 6 of 10x minus log base 6 of 5 is equal to 2. So we have log base 6 of 10x over 5. Because this is minus, is equal to 2. Simplify 10x over 5, I'm sorry. That will be 2x. Now, since this is already simplified, we can use the exponential form. So 6 squared is equal to 2x. So 6 squared is 36. Now, to find the value of x, divide both sides by 2. And x is equal to 18. Okay. Now, let's check. X is equal to 18. Let's substitute 18 here. So that will be 10 times 18. That will be 180. Now, what's the next step? We're going to use the quotient rule because we are subtracting logs. So 180 over 5, that will be 36. So exponential form, 6 squared is equal to 36. Yes. So this one is true. The next one, power rule. So power rule, if we have this kind of, we have a coefficient here, p log base b of m is equal to log base b of m to the p power. Again, p here is the coefficient besides the logarithm. So if you want to simplify that one, so the p here can be an exponent. So it can be like this one, put it here, so like this one. So let's just have the sample equation. For example, we have 2 log base 3 of x is equal to 4. Now, transform that one. 2 will now become an exponent of this argument. So that will be 2 log base 3 of x will become log base 3 of x squared. Now, exponential form, that will be 3 to the 4th power is equal to x squared. Now, 3 to the 4th power, that will be 81 is equal to x squared. Now, to find the value of x squared, get the square root of both sides, and x is equal to plus minus 9. Okay, 9 or negative 9. Now, what answers are we going to accept? So let's check. X is equal to 9. Let's check this one. Substitute it. 2 log base 3 of 9 is equal to 4. So power rule, log base 3 of 9 squared. So that will be 81. And 3 to the 4th is equal to 81. And yes, this is true because 81 is equal to 81. Next one. How about x is equal to negative 9? Substitute negative 9. Oops. Logs of negative numbers are undefined. Even if there's a power rule here and you want to save the argument from not being a negative number, no, not by a long shot. So this is already undefined, even if there's a even number coefficient here. And also special thanks to engineer Enrico Punsalan for clarifying this one. Thank you very much. I mean, I was also confused, but I've also already checked it in the calculator. Even if you have this, for example, you have this kind of problem, 2 log base 3 of negative 9, even if there's an even number in the coefficient, so the power rule could save the argument. No, it's still undefined. You may also want to check it. All right, moving on to the next rule, change of base. What if we have log base b of m is equal to log m over log b? So you can see the base will be always at the bottom, and the argument will be always at the top. So let's have the sample equation. Log base 3 of 5 is equal to x. So that will be log of 5 over log of 3. But take note, if there is no base, there's no base here, automatically it is 10. So let's go back. So how are we going to know the answer to this one? You have to use a calculator. So log of 5 is 0.699 dot dot dot. And log 3 is 0.477 dot dot dot. And if you want to have a more accurate answer, you just have to input in the calculator directly. So log 5 over log 3, like this one. And in the calculator, it says 1.46497351, or the answer will just be 1.465. Okay, rounding numbers, you can just, it depends on your professor or teacher, or it depends on the significant figure of the problem or the word problem. Okay, let's move on to the last one, reciprocal rule. We have log base b of m is equal to 1 over log base m of b. So as you can see, there's a switcheroo here. So if you just switch the argument and the base, you will just get the reciprocal of it. So let's have the equation. Sample equation. Log base 2 of 7 is equal to 1 over x. Now, if you just want to get x here, just get the reciprocal, just change the argument and the base. So here 2 will become the argument, and the 7 here, the argument 7 will become the base. And now, just get the reciprocal, and here it is. Now, how are we going to find the answer to this one? Log base 7 of 2. You have to use change of base. So, because it's not a neat number, it will become like this. 7 to the x is equal to 2. Right? You can't easily think of a number that if you have what's an exponent that could satisfy this equation. So you have to use a calculator and change of base. So that will be log 2 over log 7. Remember, the argument is always at the top and the base is always at the bottom. So log 2 is 0.301 dot dot dot, and log 7 is equal to 0.845 dot dot dot. Now to find the value of this one, just input it in the calculator. Log 2 over log 7 is equal to 0.3562071,871, or 0.356. Let me reiterate, the rounding up numbers depends on your teacher or professor on the significant number of significant figures, depending on the word problem. Let's move on. Okay, so that's already the last one. That's the end of the lesson on how to solve logarithmic equations using properties of logarithms. If you would like to comment or suggest another math and language video, or if you need help with your assignment, please comment down below. And I also have a Facebook page. I would really appreciate it if you could follow it or like. I'll just post the link at the description box. And again, this is James, your math and language instructor. Please like and subscribe, and also click the bell notification so you will be updated on my future videos of my channel, Math and Language. Thank you and goodbye.